From common products like a soft drink can to planes flying in the sky, aluminium is one of the most useful materials known to mankind. Do you know that aluminium is the most abundant metallic element found in the Earth's crust? However, the procedure used to extract aluminium is quite expensive in comparison to metals like iron. Metals are extracted using various processes depending on their reactivity. Let's talk about the extraction of highly reactive metals. The reduction of metal oxides with carbon is the general method of obtaining metals. However, in the case of highly reactive metals such as sodium, potassium, calcium, magnesium, and aluminium, their oxides cannot be reduced by carbon. These metals are present high up in the reactivity series above carbon and have a higher affinity for oxygen than carbon. So, how do we extract them? These metals are extracted by electrolytic reduction of their molten chlorides or oxides. Here, the metal salts are heated to form liquids. Let us understand the electrolytic reduction process in detail. In electrolytic reduction, electric current is passed through the metal salt in a molten or dissolved condition. The setup consists of an aqueous solution of molten metal salt placed between two electrodes connected to a battery. The electrode connected to the negative terminal of the battery acts as a cathode, while the electrode connected to the positive terminal acts as an anode. The molten salt contains positively charged metal ions. Now, we will learn how sodium metal is extracted. Sodium metal is extracted from its ore, named rock salt. Rock salt contains the compound sodium chloride. Let us understand first what happens at the cathode when electricity is passed through the molten sodium chloride solution. During electrolysis, the positively charged sodium ions move toward the cathode. Sodium ions take electrons and get converted into sodium atoms. Pure sodium metal thus gets deposited at the cathode. At the anode, the chloride ions lose electrons and get oxidized to form chlorine gas. Thus, chlorine gas is formed at the anode. The electrolysis of molten sodium chloride yields sodium metal at the cathode and chlorine gas at the anode. You are probably wondering if we can use an aqueous solution of sodium chloride instead of molten sodium chloride? The answer is no, since the sodium metal formed at the cathode will react with water in the aqueous solution to form sodium hydroxide. So, we cannot obtain sodium metal from an aqueous solution of sodium chloride. Other metals such as potassium, calcium, and magnesium can also be produced through the electrolysis of their molten chlorides. However, aluminium metal is extracted through electrolytic reduction of molten aluminium oxide. Let's learn more about the extraction of aluminium. Aluminium is extracted from its principal ore, bauxite, which is mostly aluminium oxide. The ore is first purified before electrolysis. Molten aluminium oxide contains aluminium ions and oxide ions. During electrolysis, positively charged aluminium ions move toward the cathode, while negatively charged oxide ions move toward the anode. The aluminium ions accept electrons at the cathode and are reduced to aluminium atoms. The oxide ions lose electrons at the anode and are oxidized to produce oxygen gas. Thus, by the electrolytic reduction process, pure aluminium metal is produced at the cathode. Does this metal now need to be refined? The metal obtained by electrolysis contains no contaminants and hence do not need to be refined. Electrolytic reduction produces pure metals. However, the electrolysis process is costly due to the large amounts of electrical energy required. Let's recall what we have learned about the extraction of highly reactive metals. In the case of highly reactive metals such as sodium, potassium, calcium, magnesium, and aluminium, their oxides cannot be reduced by carbon. These metals are extracted by electrolytic reduction of chlorides or oxides in which an electric current is passed through the salt in a molten or dissolved condition. Pure metal is produced at the cathode. The ore rock salt is used to extract sodium and the ore bauxite is used to extract aluminium.